Hi everybody, welcome to the recap video for the regression module. In this short video, I'm going to go over a problem that contains a whole bunch of true and false problems to help get you ready for the exam, the final exam coming up. So let's get right to it. This is a question about intra-abdominal adipose tissue. And the question is it associated with metabolic complications considered as risk factors for cardiovascular diseases? And essentially what the study is about is that we want to know, can we predict deep abdominal AT based on waist circumference? So the outcome variable here is deep abdominal AT, that's the dependent variable, and the independent variable is waist circumference. A regression was run, you can see on your screen. So here's the R output from a regression. We have the scatter plot and then the regression coefficients along with some diagnostic plots. So, and here are the questions. So at the beginning it asks which of the following are true. So the first statement, 67% of the variation in abdominal AT has been explained by its relationship with waist circumference. Is that true or false? This is true. This is basically r squared. Second question, and where would you get that from the output? Well, from the output it would be right over here, where it says multiple r squared 0.67. You can just ignore the multiple. The next question. The correlation between abdominal AT and waist circumference is negative 0.82 for these data. Well, we know that the square root of r squared is the correlation coefficient, but when you take the square root, there's a positive sign and a negative sign. In this case, we can see that the scatter plot, there's a positive linear relationship. So therefore, the correlation has to be positive. Therefore, since it asks, is it negative, this is false. Third question. An increase of 5 centimeters in waist circumference is associated with a predicted decrease of 17.3 in abdominal AT. Well, this is false, since the slope is 3.46 times 5, which is 17.3. And this is an increase, not a decrease. So that's false. Number 4. We can conclude that for all subjects as waist circumference increases, abdominal AT will increase. Well, that's not true. It's false. Okay, number 5. The estimated abdominal AT for someone with a waist circumference of 100 is 130. That's true. Number 6. The intercept gives a useful estimate of abdominal AT for a subject with a waist circumference of 0. Well, that's false, since a waist circumference of 0 is meaningless. The 7th one. From the t-test for the slope, we can conclude that there is not a linear relationship between abdominal AT and waist circumference. This is false. The p-value is very small. Number 8. The p-value for the t-test for the slope gives us the probability that the true slope is 0. Well, this is false. The p-value is not the probability that the null hypothesis is true. Number 9. After looking at the plot of the residuals versus the fitted values, we can conclude that a nonlinear model would be better to model the relationship between abdominal AT and waist circumference. This is false. There is a problem with the residual plot, but it's not an indication of curvature. The problem is that you can see here in the residual plot that basically the residual plot is the residuals are increasing as the fitted values are increasing as well. So it's fanning out in this kind of shape. So for 10, the problem is that the residual plot looks like that. It's fanning out. But that's not an indication that a nonlinear model is appropriate. So 9 is false. Number 10. The normal quantile plot shows the linear model is appropriate for these data. That's false. The normal quantile plot shows you if it's okay to assume that the residuals are normally distributed. And finally, the 11th one. We should trust the results of the t-test for the slope. That's false. The t-test for the slope assumes that the residuals are normally distributed and have a constant variance. In other words, that the residuals have a normal distribution with mean 0 and standard deviation sigma. But you can see from this plot, the residual plot, that as the fitted values are increasing, the residuals are increasing as well. This implies that the variance is non-constant, so therefore we shouldn't trust the results of the t-test for the slope. It's been a lot of fun teaching this online course. I hope you've enjoyed it as well. An announcement about ways to get help during the final exam. TAs will have office hours from December 14th to the 21st. Please feel free to drop by and ask any questions. I'll be having office hours on December 14th and December 16th from 10 a.m. to 11 a.m. in my office in Sid Smith, 6007. And if you can't make either of those, but you still have questions, then please feel free to post your questions on the Piazza discussion forum. Good luck on the final exam, and I hope to see you soon. Bye-bye.